The coordinates of this point are 1, 0, and the point that's on the positive part of the y-axis is 0, 1. So the angle for the 0, 1 is what? 90. It's a right angle. And I can say this, the cosine of 90 degrees equals 0. Or if you're in radians, the cosine of pi over 2 is 0. So I'm thinking of two vectors, and I can do the vector I and the vector j, but it could be any two vectors that form a 90-degree angle. What are their dot products going to be? 0. So I'll say, notice the dot product of two perpendicular vectors is going to be 0. Because what you're going to have, if they're perpendicular, the angle is 90 degrees, or pi over 2 if you're in radians. And so you would have this. The cosine of 90 degrees is a dot b, let's say a and b are our vectors, over the magnitude of a times the magnitude of b. So this is a fact. This is a theorem that, again, they proved earlier with the law of cosines. And I know the cosine of 90 degrees is 0. So 0 is a dot b over the magnitude of a. This is assuming a and b are non-zero vectors, because if one of them's a 0 vector, I'm in trouble. I'd have 0 in the denominator. But if this is equal to 0, the numerator has to be 0, and so a dot b. Here, this double line with an arrow in mathematics means implies. This gives us that a dot b is 0. And so that is a fact. I could call it a theorem, a corollary. I'll call it a fact right here. And this is on page 809. Two vectors, A and B, or I'm going to say perpendicular. Perpendicular if and only if A dotted with B equals 0. The book used another word besides perpendicular. Orthogonal. The book used orthogonal. So, orthogonal. And orthogonal means perpendicular. First time I ever heard orthogonal, I was in Math 1552. And it just means perpendicular.